Proposition 139. If nothing can move faster than light, and the instructions that gravity transmits across spacetime arrive at the same time as light, then gravity can't be taking a straight line to get its instructions there. General relativity predicts both EM radiation and gravity to traverse spacetime at the same constant rate. Proposition 140. Potentially, some as of yet unknown wavelength of electromagnetic radiation is responsible for the force carrier that lets mass dictate to spacetime where and when and how much to bend and warp. If the wavelength is at subquantum scales, we may never be able to properly measure the waves of gravitational attraction. Proposition 141. Gravitational waves of attraction are the force carriers of gravity, not the hypothetical particle we call the graviton. Gravity is a force that traverses spacetime to tell all different areas of spacetime not only how much to bend and warp, but where and when. Proposition 142. None of our planets orbit our sun. Our moon does not directly orbit our planet. Our moon orbits where our planet was 1.3 seconds ago, while each planet continually orbits different spots where our sun previously was. Proposition 143. Geodesics created by gravity wells can be impacted by other overlapping gravity wells and are themselves hurling through spacetime as an interconnected mesh of overlapping gravity wells. It is this mass energy cohesion to spacetime that holds our local relative spacetime together and fights off the expansion caused by all of our nested parent co-moving frames of reference that are losing their own mass energy cohesion to their own tensor meshes of overlapping relative gravity wells. Proposition 144. Each co-moving frame of reference has a tensor mesh of gravitational attraction where each point in relative co-moving space can see hundreds, thousands, even millions plus of separate relative tensor strengths tugging in all different directions. That mesh co-moves together with all the co-moving bodies themselves, and all combined behaves for the most part like an inertial reference frame. Proposition 145. Since few orbits are circular and most are elliptical, the chains going from perihelion to aphelion would involve some form of acceleration and deceleration. So our nested succession of parent co-moving frames of reference tells us there is no such thing as a true inertial frame of reference. There are only relative inertial frames of reference, which is ironic, since inertial reference frames are the cornerstone of relativity. Proposition 146. When we have a co-moving frame of reference, then multiple bodies would be sending out spherical waves of gravitational attraction, telling spacetime where and when and by how much to bend and warp. Those waves, if they move in phase, could aggregate to see a larger amplitude, able to create a deeper gravity well along the areas of spacetime where those waves provide instruction to. Proposition 147. If we consider that multiple stress-energy momentum tensors moving with the same relative trajectory and relative velocity could aggregate to produce deeper gravity wells than otherwise expected, we would predict to see galaxies held together that should otherwise fly apart. Proposition 148. If the attractive force of gravity moved as a wave and waves in phase increase the overall amplitude, then we would predict seeing areas where a gravitational lens provides a stronger effect than the reported mass predicts it should. Proposition 149. If there was no pea-sized hot dense center that we started from, but instead our cosmic web is the leftover trails of past superluminal collisions, then no dark matter is needed to account for the cosmic structures we see evolving today, and diffuse galaxies would be predicted to exhibit less dark matter. Proposition 150. Dark matter will not be found with macho wimps, but will be found as an aggregate function applied against the stress-energy momentum tensor in the field equations of the general theory of relativity. In total, 3 changes are needed to make general relativity complete. Proposition 151. Dark energy and dark matter may both be due to missing parameters inside the field equations of general relativity. A total of 3 changes to Einstein's field equations solves dark energy, dark matter, and the center of each black hole's event horizon. Proposition 152. First, dark energy is a variable ratio, capital lambda over lowercase lambda, comparing the strength of the localized overlapping gravity wells to the succession of nested overlapping gravity wells within each parent co-moving frame of reference at any point in time and space. Proposition 153. Secondly, dark matter might be an aggregate function applied to the stress energy tensor to define the effects that multiple bodies sharing the same co-moving frame of reference can have on space-time. Proposition 154. Thirdly, we need to set a lower bound of 0.08 femtometers where the strong nuclear force takes over and gravity loses. Any energy expended by gravity to try to condense quarks past the limits of quark degeneracy pressure just end up creating more quarks. Proposition 155. There are no singularities at the center of black holes, but instead a polyquark or possibly a densely packed quark soup of constantly transforming quarks. For objects that appear to be so black, if we could see the quantum chromodynamics at the center of black holes, there is a chance it might be quite a vibrant color show. Proposition 156. All pockets of spacetime have their own spheres of influence, multiple spheres that emanate outwards from each pocket. They can include thermal heat, visible light, sound, visible matter, gravitational attraction, magnetic attraction, electric fields, other radiation, odor, possibly even something we have not even learned about yet. Each emanates in waves that dissipate based on the resistance met, converting the amplitude into each additional wavelength.